Hello and welcome to Math 135. This is Tracy and we are going to go ahead and do an example with a binomial distribution. Now remember that a binomial distribution is a discrete probability distribution. That means that our outcomes can only take on specific values. Our outcome in a binomial distribution, a binomial experiment, is the number of successes. All right, here is the example we are going to use. We are going to use our TI to fill in the probability distribution table for the number of Mexican Americans selected for jury duty for a given jury in a county where 80% of those eligible for jury duty are Mexican American. Before we get started, we want to answer a couple of questions. Is this a binomial experiment? What is a success? What is P, the probability of success? What is X, our random variable, in words? What is N, the number of trials? What values can X, our random variable, take on? So to determine if this is a binomial experiment, we need to make sure a few conditions are met. Our first condition is that we can only have a fixed number of trials. We can only conduct whatever our experiment is a specified number of times. In our experiment, what we are doing is we are looking at a jury and counting the number of Mexican Americans selected. Because a jury only has 12 members, each member is a trial for our experiment, we do indeed have a fixed number of trials. 12 trials because we have 12 jurors. For each trial, each juror, we need to make sure we only have two possible outcomes, a success or a failure. Because we are counting the number of Mexican Americans on our jury, then each jury member only has two possible outcomes. Either the juror is a Mexican American or the juror is not. So yes, there are only two possible outcomes for each trial in our experiment. Are each of these 12 trials independent? Well, yes, because we have a large population. 80% of the population is Mexican American. It's a big enough population that each person we pick is independent of the other. If we had a tiny population and we were picking a lot of people, then no, the trials wouldn't be independent. But in this case, they are. And the probability of success needs to be the same for each and every trial. Each and every juror has to have the same probability of being Mexican American. Because we have a large enough population and we have 80% of that population being Mexican American, that probability of being Mexican American is the same for every member on the jury, as long as everything is fair. And here we just have the answers that we talked about on the slide before. What is the success in our case? And what is P, the probability of success? A success is the outcome we are looking at, the outcome we are counting. It's whatever it is that we want to know. So we want to be careful not to get too hung up on the word success. Sometimes people get really confused because some experiments, especially in the medical field, we are counting the number of heart attacks or the number of deaths due to a disease or the number of people killed in a motorcycle accident. And a success really isn't very successful. So remember, success just means what is it that we're counting. And in this case, we are counting the number of Mexican Americans selected for jury duty. So a success is selecting a Mexican American for jury duty. And the probability of success in this population, 80% of those eligible are Mexican American. So the probability of a given juror being Mexican American, if that person is randomly selected, is 0.8. And here we go. Here are the answers to the questions we talked about on the last slide. What is X, our random variable, in words? Remember that our random variable is whatever it is that we're counting. we are counting the number of Mexican Americans selected for jury duty on a specific jury. So X is the number of Mexican Americans selected for jury duty. What is N? And N is the number of trials. And what values can X, our random variable, take on? Because our experiment is looking at the number of Mexican Americans on a given jury, the number of trials, the number of people that we select for the jury is just 12. N equals 12. Because a jury contains 12 jurors, the number of successes, the number of jurors who are Mexican American can take on anything from 0. We can have 0 jurors selected who are Mexican American, or 1 or 2 or 3, all the way up to all 12 jurors being Mexican American. And here are the answers typed up on our slides. This is the table we want to fill in. This is the probability distribution table for the number of Mexican Americans selected for jury duty on a given jury. X is the number of Mexican Americans selected. The second column is the probability that we have that number of Mexican Americans selected for the jury. So where X equals 3, the probability that X equals 3 is the probability that exactly 3 jurors are Mexican American. And then the next column is the cumulative probability. We want the probability that X is whatever value we're at or less. So we have a couple boxes filled out. The probability that X is less than or equal to 6 is the probability that 6 or fewer jurors will be Mexican American. That's the probability that we have either 0 or 1 or 2 or 3 or 4 or 5 or 6 Mexican Americans selected for a jury. The other box that's somewhat filled out, when X equals 10, the probability that X equals 10 is the probability that exactly 10 jurors on a jury will be Mexican American. To find the probability that we have a specific number of successes, that X equals some value, here what we have is a list of the steps you can take. On the next slide, if you click on the video there, it will show you how to use your calculator step by step with all the buttons pressed, and then a list of keystrokes to tell you, using your calculator, how to calculate the probability that we have a specific number of successes. Hello and welcome to Math 135. This is Tracy, and we are going to use our TI graphing calculators to work on the problem that you have in your notes. In the problem we are going to fill out a probability distribution table for the number of Mexican Americans selected for jury duty in a county where 80% of those eligible for jury duty are Mexican American. In other words, we are going to find the probability of a specific number of successes in a binomial experiment. So we know that we have this binomial experiment with 12 trials because each jury has 12 members. And for each trial, each jury member, there is an 80% chance of success, an 80% chance that the juror we pick is Mexican American. So to calculate the types of probabilities we're looking at, we are going to use the second favorite button on our calculator. This is the distribution button. So when we hit second vars, we come up to this screen, and you can see the screen here on your right. We want to work with a binomial distribution. So we can scroll down, because we don't see binomial in the list we have so far. Scroll down. And we have a couple of binomial distributions here. We have a binomial PDF, see the letter P here. And for B, that was A, and for B we have a binomial CDF. Now the PDF is what we want in this case, so we can go ahead and hit enter. We want to find the probability of a specific number of successes. That's the PDF, the probability distribution function, the probability that we have exactly X successes. So we have 12 trials because this is a jury, and a jury has 12 members. Our p-value, the probability of success, is 0.8 because 80% of the people we could choose from are Mexican Americans. So we have an 80% or a 0.80 probability of selecting a Mexican American for each member of the jury. And then we want our X value. Let's just pick a specific number of jurors that we want to be Mexican American. How many successes do we want? Well, we're going to say 10, just as an example. What's the probability that if we have 12 members in a jury, 80% chance that for each member being Mexican American, that we have exactly 10 Mexican Americans? So we go ahead and paste that onto our main screen. Now, if you have one of the calculators that did not prompt you with number of trials, P, X value, you will just type in binom PDF. You will just do second vars to get your binom PDF, and you will have an open parenthesis. Then you need to know what order to fill in your number of trials, comma, your probability of success, comma, the specific number of successes that you want to know a probability for. So in your notes that you have for your exam, write that down. Binom PDF NPX, or binom PDF, number of trials, comma, probability of success is a decimal, comma, number of successes. So when we go ahead and hit enter here, we see that there is a 0.2834 blah, blah, blah chance that in that jury, exactly 10 members are Mexican American. So when we go back to our binomial distribution table, in the box that says the probability X equals 10, we would put this number. Now I'm going to give you the completed probability distribution table. I recommend that you go in and try this process a couple of times to make sure that you're getting the correct answer. All right, well, thank you. Here we want to find the probability that we have a specific number of successes or fewer, the cumulative probability. Again, here is just a list of the steps. On the next slide, you can click on the video to see an emulator for our calculator with all of the keystrokes and a list of the keystrokes and what you'll see on your screen. Hello and welcome to Math 135. This is Tracy, and we are going to use our TI graphing calculators in order to calculate a cumulative probability for a binomial distribution. In other words, we are going to use our calculators to find the probability that we have a certain number of successes or fewer. A cumulative probability is the probability of having 0 or 1 or 2 or 3 all the way up until some number. So we are going to do that for the same experiment that we've been working on, selecting jurors for a jury in which 80% of the population eligible for jury duty is Mexican American. So again, to calculate these types of probabilities, we're going to go to the second favorite button we have in our stats class. Remember, stat was our first favorite button. We did all kinds of stuff in there. Now, because we are dealing with probability distributions, we go to the distribution button. So second, vars, and we look at our distributions. So again, we want a binomial distribution. So we need to scroll down. None of these are binomial. Down, down, down. This is the one we worked with last time, the binomial probability distribution function. That was when we wanted to calculate the probability of exactly some number of successes. Now we want the one below that, the binomial cumulative distribution function, the probability of some number of successes or fewer. So go ahead and hit enter. And we do this exactly the same way we did before. We enter the number of trials, since we are selecting members for a jury, there are 12 trials. Each member of the jury is a trial. 80% of the population is Mexican American, so the probability for each juror to be Mexican American is 0.8. And this time, let's calculate the probability that 6 or fewer of the jurors are Mexican American. So go ahead and hit 6. And enter to paste that onto our main screen. Again, if your calculator does not prompt you for the number of trials, for P, the probability of success on a given trial, or for the number of successes or fewer, then you need to have this written in your notes. You know that you still go to second vars to get your binom CDF for a cumulative distribution function for X successes or fewer. And then in the parentheses, maybe in your notes, write number of trials, comma, P, probability of success on a given trial, comma, the number of successes or fewer. Go ahead and hit enter, and that 0.019, blah, 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 is the probability that 6 or fewer jurors on a trial, on a jury with 12 jurors, is going to be Mexican American. All right, thank you. As always, if you have any questions, please let me know. This is the completed table. I recommend that you go in and you check and make sure that you can get these values. Now, when we look at the second column, the probability that X equals a value, you see this 0 plus. What that means is that the number you get on your calculator is so tiny. For example, for that first value, the probability that X equals 0, you will see on your calculator 4e10 negative 9. What that means is 4 times 10 to the negative 9, or 4, and then move the decimal place left 9 places. And that is such a tiny value. It, for all practical purposes, might as well be 0, but it's not exactly 0. It's not impossible to get no Mexican American jurors. It's just so unlikely that we really don't even think about it. So we use 0 plus as a symbol. Now notice in the next column, the probability that X is less than or equal to a value. When we get to 5, we have that the probability X is less than or equal to 5 is the probability that X is equal to 4 plus the probability that X is equal to 5. That's where that 0.004 comes in. So we can fill in that column just by adding up the values from the column to the left of it. Or we can use our calculator, as you saw in the videos, to go ahead and calculate those without having to add up a bunch of things. Now, when you add up all possible probabilities, the probability that X equals 0 or 1 or 2 or 3, all the way up to 12, because that is your entire sample space, the sum of those probabilities has to be 1. And you can see that in your total column, or I'm sorry, your total row at the bottom. When you add up all your probabilities, you'll get a 1. It doesn't make sense to find a total for your cumulative probability distribution column. There's no reason to add those up. Here is a histogram of the information that we had on our table. On the horizontal axis, we have the number of Mexican American jurors on a jury, or the number of successes. And then on the vertical axis, we have the probability. So we can see that the highest probability is to have 10 Mexican Americans selected for a jury. And the probability of that is somewhere between 0.25 and 0.3. Between 25 and 30% chance that exactly 10 members of a jury will be Mexican American in this county. And it tapers off from there. Now let's use these probabilities to answer some application questions. This actually came up from another statistics book that I have in talking about a court case. It was alleged that jury selection was discriminatory, that in a county with 80% of the population eligible for jury duty to be Mexican American, juries were being chosen with too few Mexican American jurors, that the Mexican Americans were being discriminated against in being selected for jury duty. And since such a high percentage of the population was Mexican American, there's a good chance that many of those being on trial would be Mexican American, just because that's what the majority of the population was. So it wouldn't be fair if there were too few Mexican American jurors, because then the defendants would not be tried by a jury of their peers. So this was kind of important. So here are a couple questions we want to ask. What's the probability of having 6 or fewer jurors who are Mexican American? Anything with a probability less than 0.5, which is the same as 5%, is considered unusual. Is it unusual to have 6 or fewer jurors who are Mexican American? In other words, if we get some juries out there with only 5 or 4 or 2 Mexican Americans, should we question the integrity of the jury? And what is the probability of having more than 7 jurors who are Mexican American? So, what's the probability of having 6 or fewer jurors who are Mexican American? This is the example that we worked with the calculator a few slides ago. The probability that x is less than or equal to 6 is 0.019. And you could also find that by looking back at the table, if you're given a table as opposed to enough information to put this in your calculator. Now, if we want to, we can take that probability and convert it to a percent, multiply that 0.019 by 100%, and you get 1.9%. Now, is that 1.9%? The probability of having 6 or fewer jurors who are Mexican American is 1.9%. Is that unusual? Well, again, anything with a probability less than 0.05 or 5% is considered unusual. The probability of a jury having 6 or fewer Mexican Americans, that is, having 0 or 1 or 2 or 3 or 4 or 5 or 6, is only 1.9%. This is smaller than 5%, so yes, it is unusual to have a jury with so few Mexican American jurors in a county where 80% of those eligible for jury duty are Mexican American. You shouldn't expect less than half. It's unusual for half or less of those jurors to be Mexican American when 80% of the population is Mexican American. Now here we have a question. What is the probability of having more than 7 jurors who are Mexican American? Our calculators do not have a button for this. Our calculators will give you the probability of having exactly X successes, so we can find the probability of having exactly 7, or we can find the probability of having 7 or less. Those are the 2 buttons on our calculator. If we want anything else, we have to do some arithmetic with the buttons that we do have. So if we want the probability of having more than 7 jurors who are Mexican American, we can figure that, well, more than 7 means we want the probability that we have 8 or 9 or 10 or 11 or 12. We can do this the long way by adding up the probability that we have 8 plus the probability that we have 9 plus the probability we have 10 plus the probability we have 11 plus the probability we have 12. Ugh. Do we really want to do that, especially if we have something like 500 patients in a clinical trial and we want the probability that 100 or more have heart attacks? No, we're not going to go and add 400 things. So what we're going to do is do some subtracting. If we want the probability that we have more than 7 Mexican American jurors, then we do not want the probability that we have 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. In other words, we do not want the probability that we have 7 or fewer jurors. So we are going to subtract that from 1. Remember, 1 is everything. If we only want 8, 9, 10, 11, 12, then we subtract away 0, 1, 2, 3, 4, 5, 6, and 7. 1 minus the probability that x is less than or equal to 7, which is 1 minus that binomial CDF, that cumulative distribution function, the 7 or fewer. And we can type that all in one line in our calculator, 1 minus, and then that second vars, binom CDF, the number of trials is 12, the probability of success on a trial is 0.8, and we want to subtract off that 7 or fewer, so 7 for our x value. And we find out that the probability that you have more than 7 Mexican American jurors in a county where the population is 80% Mexican American is 0.927. Multiply by 100% and you get a 92.7 chance that you have more than 7 jurors on a jury in this county. 92.7% chance that you have 8 Mexican American or 9 or 10 or 11 or 12 Mexican American jurors in this county. Alrighty, well, that is an example involving binomial distributions and using your calculator and all that good stuff. As always, if you have any questions, please let me know.